Hi everyone, myself Dr. M. Karthik, working as Assistant Professor in the Department of Electrical and Electronics Engineering, SRM Madurai College for Engineering and Technology. Today we are going to discuss in detail about an introduction to EHVAC and HVDC transmission, which comes under transmission and distribution. We all aware that we have AC and DC power supplies in which DC is extended as HVDC, that is high voltage DC transmission, and AC is extended as HVAC, high voltage AC transmission, EHVAC, extra high voltage AC transmission, and UHVAC, ultra high voltage AC transmission. For getting benefited with these power supplies, we should understand the possibilities and the reason for transmission and distribution. HVAC power transmission. HVAC power transmission has been brought into the picture due to the liberalization of electricity market, renewable energy rise, increased environmental awareness, due to which the possibilities for transmission line in high voltage network has been derived through overhead line, cable line and gas insulated line. Based on the requirement of choosing a proper transmission line in high voltage network, a suitable decision should be derived. High voltage AC transmission, it is considered to be most economical, environmental friendly and low in losses. Voltage level for HVAC in Austria and major parts of Europe were 110 kV, 220 kV and 380 kV. The advantage of using high voltage AC in transmission is easy transformation of energy between the different voltage levels, which is considered to be convenient and safe in handling with respect to the applications. The unfavorable condition of using HVAC is transmission and compensation of reactive power, stability problem, frequency effects can cause voltage difference and load angle issues at long lines. The configuration of EHV and UHV lines are: EHV stands for extra high voltage and UHV stands for ultra high voltage. So here the major consideration for the selection of suitable switching scheme for an EHV and UHV substations are: the scheme should fit in the planning criteria used to design the connector transmission system. The system should be stable. If a permanent fault occurs on a line, it is therefore important to limit as much as possible the system instability caused by outage of line, transformer or generators due to substation fault. Second one is repair or maintenance of the equipment should be possible without interruption of the power supply. Followed by expansion of substation should be very easily possible, and large clearance are required at EHV and UHV level. Therefore, in order to obtain lower structure and facilitate maintenance, it is also important to design substation preferably with not more than 2 level of bus bar. Finally, a practical site consideration at a particular location should be made, which is lack of adequate flat area for layout of equipment in the substation may also sometimes influence the choice of layout. Types of conductor in HVAC. A conductor is one of the most important components of overhead line. Selecting a proper type of conductor for overhead line is as important as selecting conductor size and economic transmission voltage. A very good conductor should have the properties like high tensile strength in order to withstand mechanical stress, high electrical conductivity, relatively lower cost without compromising much of other properties, lower weight per unit volume. Copper was the preferred material for overhead conductors in earlier days, but aluminum has replaced copper because of much lower cost and lighter weight of aluminum conductor compared with copper conductor of same resistance. There are some materials that are considered to be good conductors like copper, aluminum, cadmium and copper. These are the different types of conductors which supports for transmission. AAC, that is all aluminum conductor, AAAC, all aluminum alloy conductor, ACSR, aluminum conductor steel reinforced, and ACAR, aluminum conductor alloy reinforced. So now we are going to discuss about the cost of transmission line. For discussing about the cost of transmission line with respect to AC transmission and DC transmission, we have to compare the distance with the price. So when we compare with the distance, after reaching the break-even distance, the cost required for transmitting the AC power is going to be high compared to the DC. So up to short distance, the AC is affordable, and for long distance transmission, our DC is going to be affordable. HVDC transmission. The full form of HVDC is high voltage direct current transmission. Uses the direct current for transmission of electrical power, and it should be used for over long distance. So here we have two AC systems having different frequencies can be linked up together by means of HVDC link, and HVDC technology is used to transmit electricity over a long distance. That is, for bulk power transmission, HVDC is affordable. Why we want to go for DC transmission? As I said, two conductors only required, it is less expensive, and it can be used for long distance, and so the losses are very much less compared to HVAC. Comparison of AC and DC transmission. High voltage AC transmission is having several limitations like length of the line, uncontrolled power flow, over voltage, low voltage during light loaded condition as well as overloaded condition, stability problems, fault isolations. The advantage of HVDC is the ability to transmit large amount of power over long distance with low cost and with low losses than AC. So this is the major point why we are incorporating high voltage DC transmission for long transmission. HVDC transmission allows efficient use of energy source remote from load centers. Depending on voltage level, construction details, losses are quoted as about 3% per 1000 km. In a number of applications, HVDC is more effective than AC transmission. Example, undersea cable where high capacitance causes additional AC losses. For example, 250 km Baltic cable between Sweden and Germany, and 600 km Nordnet cable between Norway and the Netherlands. So this is the comparison of what we have seen previously, that is the break-even distance. For short distance transmission, HVAC is affordable compared to DC, whereas for long distance, that too for bulk power transmission, our HVDC is going to be affordable compared to HVAC. So by comparing the size of the conductor, we need 3 conductors for HVAC transmission, and we need only the single conductor for HVDC transmission, which means the requirement of copper, the requirement of the conductor is less compared to HVAC. Direct current conserves the forest and also it saves the land. Say for example, you can look into the picture what I'm sharing now. Here, if we want to erect a tower for HVAC of 400 kV, I need 2 different towers, whereas if I want to transmit HVDC of 500 kV, I can use only one tower, which is of 46 meter. So by comparing the land area for HVAC of 400 kV, I'm in a need of 90 meters of land area, whereas for HVDC I need only 46 meters of land area for transmitting the bulk power. So by incorporating the HVDC for transmission, the land has been saved and the forest has been conserved to a larger extent. There are less corona losses than HVAC at same voltage and conductor diameter, and less radio interference in HVDC, and the direction of power flow can be changed very quickly, and HVDC has greater reliability, that is, in bipolar DC is more reliable than 3-phase high voltage AC transmission, and DC require very less number of insulation compared to AC. Finally, an optimized DC link has smaller tower than the optimized AC link of equal capacity, which we have discussed earlier, and DC line is parallel with AC link. So overall observation, if you want to transmit the energy for a short distance, AC transmission is supportable with moderate cost, and if you want to transmit large amount of power for a long distance, then high voltage DC transmission is going to support with low losses and transmitting bulk power for a long distance. Thank you.